Okay, so let's talk now about electromagnetic induction. I'm going to go back to the overview for a second. What we've talked about essentially so far is how a changing electric field can produce a magnetic field. That's what we talked about in the previous video. But now we're going to talk about electromagnetic induction, which is when a magnetic field changes or moves to produce an electric field, this electromagnetic induction. I'll write that down here for you. So we're kind of on the other side of that coin now. On one side of the coin, we have electric fields making magnetic fields. Now we're on the other side of that coin talking about how magnetic fields can produce electric fields. So let's dive in. All right, so let's look at the key idea. A changing magnetic field in a conductor, such as a copper wire or a circuit, will produce an electric current in the conductor. And it's key, I want to emphasize here, that the magnetic field must change to produce that current. Okay, and then one way to do this is just to move a bar magnet near a solenoid of conductive wire. So I'm going to actually demonstrate this. Okay, so what we have here is a coil of wire, and you can see the electrons are shown by the blue dots, and they're not moving. There's no current right now, and the light is not on. And here I have a magnet, which is also not moving, and so the magnetic field is static. It's not changing. You can see all the little compasses. The magnetic field is not changing, but I can change the magnetic field simply by moving my magnet. Okay, and you might see a little spark in that bulb. But when I move the magnet through the coils, that's where I'm going to see the biggest change. That's what's going to change that magnetic field the most. And if you look inside of that, let me see if I can put this in there. If you look inside, well, you can see the smaller compasses inside. When you look inside of that coil at the little compasses, they're showing that the magnetic field is changing direction. So that's a changing magnetic field. And the quicker that magnetic field changes, the brighter my bulb is. The more current I get, the faster those charge moves, and the brighter the current. But if I just place the magnet inside, we're not going to see anything happen. And that is because that the magnetic field must be changing in the conductor. All right, so it's only when the magnetic field changes or when I move my bar magnet that creates a current, causes my charges to move, which causes my light to come on. Okay, and that is electromagnetic induction. All right, so what are some applications of this? I want to show you at least one application of this. So what we can do with electromagnetic induction, this is actually how we get most of our power. Most power plants have some kind of turbine, which we see here, that will spin, which is essentially a magnet, and it's near a coil of wire. And when that magnet moves, that's going to cause the charges in this wire to move and give us power. Okay, so we can spin this turbine in a lot of different ways. We can use a waterfall. We can use rising heat from burning coal, which will probably be steam. We can actually boil water and make steam with radioactive materials in the nuclear power plants, but we're going to turn this turbine somehow, either by rising steam or falling water, and like this. Okay, and we see that the magnet is now moving and the field is now changing, shown by the compass inside of the coils. It shows us that the field is always changing, and we get this current that goes back and forth. This is called an alternating current, and this is how we power all of our homes. Is there some sort of turbine spinning a magnet, which induces a current in a coil of wire through electromagnetic induction and powers our homes. Okay, it's a little bit more complicated to this, but this is essentially how a generator works at your power plant. So I hope y'all have enjoyed this. Let me go back to the main idea. I want to end on the main idea. A changing magnetic field in a conductor will produce an electric current in that conductor. All right, I hope y'all found this helpful, and I will talk to you soon.